we are continuing with the tutorial 2 for this semester. Just like we solved the midterm earlier, so this part of the tutorial we will solve quiz 3. Let us now go to question 2 of the quiz, and you know the pattern. Generally the first question is multiple choice or true false, which you directly do on the Moodle, and question 2, whether it is one part or two parts, is where the numericals or small theory questions start. So this is question 2A for section 10 quiz 3. Define solidus, liquidus and solvus lines. Part 2 of this, briefly explain what is chord structure in alloys and how it can be removed. So this is a simple thing. If you know the phase diagram, then the first part. If you know cooling rates and so on, then the second part. So let us see. I am just repeating any diagram in which all the three lines are there. So if you see, right, this is the liquidus line, this one or this one. This is the solidus line, this one or this one, right? And this is the solvus line, here or here. So liquidus, solidus and solvus lines. And if you want to write the definition properly, then solidus, line on the phase diagram below which only solid phase exists, right? So if this is solidus, then below it is only the solid phase. Above it is solid plus liquid, right? So a very good definition of solidus, line on the phase diagram below which only the solid phase exists. Next, liquidus, line on the phase diagram above which only solid phase exists. So sorry, only liquid phase exists. My typo error, only liquid, right? If this is the liquidus line, liquidus, then above it will always be liquid, below it will be mixed. So please, sorry for my typo. Line on the phase diagram above which only liquid phase exists. And solvus exists on non-isomorphous systems, right? Isomorphous system, solvus is not there, but here solvus line is there. This is the solvus line. So line on the phase diagram which separates one solid phase and two solid phases, right? So if this is the solvus line, on one side is alpha, on the other side is alpha and beta. If this is the solvus line, on one side is beta, on the other is alpha plus beta. So solvus line is the line at which you have on one side only one solid phase, on the other side two solid phases. Let us continue the same question, but the second part of question 2A, which was about chord structure. So I am just showing you a slide from the lectures that if non-equilibrium cooling is there, which is rapid cooling, then the solidification is delayed, which results in chord structure. A small cores of solids are formed rather than one homogeneous solid. And if this type of a chord structure is there, then a heat treatment called homogenization is done so that the cores are gone and you get a uniform structure, right? So this is already explained, but in words, non-equilibrium solidification is carried out at a faster than normal cooling rate, resulting in a chord structure which is non-homogeneous. Chord structure can be removed by a heat treatment process called homogenization. So of course the details are there in the lectures and so on, but as an answer in a quiz, this much is more than enough. Let us go to the second part of question 2, question 2B. A 2.5% carbon hyper-eutectoid plain carbon steel is slowly cooled from 1250 Celsius to a temperature just below 1148 Celsius. Calculate the mass fraction of eutectic austenite in the steel, and the iron carbon diagram is given. So once again, my request that stop here and take your pencil and paper and start solving it so that you get the practice and you don't go to the next slide until you are 100% sure that you have done this right. So we have done right. So if you are listening to me now, otherwise you had paused me earlier, right? If you are listening to me now, it means that you have solved it. So now it is the iron carbon diagram already, iron carbon diagram already. The temperature just below is 1148. So it is this eutectic temperature. This is eutectoid temperature 723 in iron carbon steel diagram, and this 1148 is the eutectic temperature. So just below this line. And earlier you are at 1250, right? So you are somewhere at 1250. And 2.5% carbon hyper-eutectoid. You know, this is the eutectoid steel. So below this is hypo-eutectoid. After this is hyper. So 2.5. This is 2. This is 3. So your vertical line is from here. So this is that. And at 1250. So you will see that if you go there and it is 1250, then you are somewhere here and so on. Maybe, right? So it will be all liquid at that, if I am not wrong, but that is the thing. And then from there you are cooling, right? Whatever, even if it was here, you are cooling from 1250 to just below 1148. So then, because this is your vertical line and this is your temperature line, so draw a horizontal line just below this. So if it is just below this, then the left point cuts at 2.0% carbon and the right point cuts at 6.67% carbon. And in the middle, you have 2.5%, right? So 2.5 and this one. And you are asked to find eutectic. But if you remember, above this line, if there is any gamma formed, austenite, any gamma formed above this line, that is the pro-eutectic gamma. Below this line, there is total gamma. So what you will find will be total gamma. And from the total gamma, if you subtract the pro-eutectic gamma, then you will get the eutectic. So you will have to draw a tie line just above 1148 by yourself. The question has not asked you, but because you want to find eutectic, and eutectic is total minus pro-eutectic. So draw a line just above 1148. So on the left you have 2, on the right you have 4.3 this time. And then you will solve it, right? So this requires understanding, right? And we have explained it in a lot of detail in the lectures. We have solved exactly similar problems in the solutions, in the class examples and so on. So if you have done practice and you have revised, then there was no issue. But for those guys who did not revise or something, then this would be so, right? So the key is that eutectic is total minus pro-eutectic. So let us see, right? So I am just repeating the diagram, and then this is the tie line. Above 1148. Above 1148, on the left is 2, in the middle is 2.5, and on the right is 4.3. Right? On the right is liquid, on the left is gamma austenite. So this is it. So this is gamma. So if you want to find the mass of gamma, then it is this minus this upon this minus this, the total. So therefore, pro-eutectic gamma is 4.3 minus 2.5 upon 4.3 minus 2, whatever it comes out to be. This is the pro-eutectic gamma. Next time you will go below the line, right? So just below 1148, left is 2, right is 6.67, in the middle is 2.5. So once again you find gamma, but this is the total gamma this time. Total gamma. So total gamma is 6.67 minus 2.5 upon 6.67 minus 2, whatever it comes out to be, right? And it is left side is austenite, right side is cementite now, cementite. And your answer is eutectic gamma is the difference. So eutectic gamma is total minus pro-eutectic. So total minus pro-eutectic, whatever percentage in fraction, 0.11029, in percentages 11.03%. So this was not a complicated problem, not a difficult problem, but you must have been present in the class when this lecture was being explained and this solution was being done, and you must have practiced this a little. And very similar one, this is iron carbide diagram, But other eutectic diagrams were also there, other alloys where we have done similar work, right? And of course, because it is the iron carbon diagram, so therefore you have two interesting points. This is the eutectoid point, which we are not asking to, and this is the eutectic point. So above this temperature pro-eutectic, below this temperature eutectic. Eutectoid, above will be pro-eutectoid, below will be eutectoid, but to the left and right is the composition. Less than 0.8% carbon is hypo-eutectoid, 0.8% carbon is eutectoid, and anything more than 0.8% carbon is hyper-eutectoid steel. So this was question 2. Now we are going to question 2a of the second section 20, right? The first one was a mixture of multiple choice and so on, so that was the same for both the sections. But then the second question, question 2 for section 10, we just completed. Now question 2 for section 20. So part A of that. Name the 3 invariant reactions that take place in the iron carbide phase diagram. Write the equations for any 2 of them. You know, right, that this invariant reactions are special reactions, and there is a small slide in the iron carbon chapter, iron carbide diagram chapter, where these 3 are there. So let us see. The 3 invariant reactions are peritectic, eutectic, and eutectoid. Peritectic happens, if you remember, at a very high temperature of 1400 plus, where the delta ferrite is there, delta ferrite. So peritectic, liquid plus delta ferrite at 1495 changes into gamma. And of course, liquid of 0.53% carbon and delta of 0.09% carbon and gamma of 0.17% carbon. But if you are writing this equation, even if the carbon percentages are not there, you just write peritectic means liquid plus delta changes into gamma at plus 1400. Even if you don't remember 1495 exactly, if you say plus 1400, then I will take it to be okay. Similarly, eutectic, you know eutectic is that liquid changes into 2 solids, right? So the liquid at 1148 changes into 1 solid, gamma austenite, and the other solid, iron carbide or cementite, whatever you call it, percentages are there. The third one is eutectoid. You know, 1 solid changes into 2 solids. So the solid gamma, which is austenite, changes into alpha or ferrite, and cementite or iron carbide, whatever you call it. And you were required to write any 2 of them correctly, not all the 3 of them. So first name peritectic, eutectic, eutectoid. These are the 3 invariant reactions. And then these are the equations. And as I am saying that the total correct equations are shown here with the actual percentages, carbon percent and so on, the compositions. But we don't know, we don't want you to do that exactly. If you just say liquid to gamma and cementite, and roughly 1100 plus, even if you don't write 1148, if you just write plus 1100, then we will take it to be a correct answer. Question 2b of the same one. Consider the binary eutectic phase diagram shown in the figure. It is a copper silver diagram. Make phase analyses of a 80 weight percent silver, 20 weight percent copper alloy at these temperatures, at 900 Celsius and at 780 Celsius minus delta T. So just below 780. In the phase analysis, though you should know that, include what are the phases present, what are the chemical compositions of the phases, what are the mass fractions of the phases, and sketches of the microstructure. So once again, I would ask you to stop here, solve it again as a practice, right? Because it is a practice for the final exam also, and then continue only when you are done with it.